Now, you know what? I heard Javier just saying, Mr. Bauer, I'm not having fun yet. All right, well, I'm going to give you some fun. What's going to make it more fun? Well, it's going to be more fun if we have letters instead of numbers. What do you think about that, Javier? Yeah. All right, don't blame Javier. This was my idea. All right, so here we go. Tangent to the curve y equals x squared plus ax plus b, where a and b are constants, is 2x plus y equals 6 at the point where x equals 1. Find the values of a and b. All right, so we've got some kind of quadratic, right? So quadratic. Okay, and then at x equals 1, the tangent is 2x plus y equals 6. Now, I don't know what that looks like, but if I subtract the 2x to the other side, I'm going to have y equals negative 2x plus 6, right? Subtract the 2x to the other side. Now I know this looks like a linear graph with a slope of negative 2, so this now will look something like this, right? All right, so here's my quadratic right here, and then this is the tangent. You don't have to draw this, but sometimes it's helpful to kind of visualize what's going on. So there's the point where they're touching. Now, where are they touching? Well, they're touching at the point where x equals 1. So they're touching right there. Now, the x value there is 1. Do you know the y value? Why, of course you do. If it's tangent, that means that that point is on that straight line. So we can put that 1 into the equation. We can go y equals negative 2 times 1 plus 6, and then I get y equals negative 2 plus 6, which means that y equals 4. So 1 comma 4 is that point right there where the point where this line is tangent. Now, this leads us to a very important piece of information. Anytime that a line is tangent to a curve, that tells you two things. Number one, it tells you they have the same slope at that point. And number two, it means that they actually share that point. Okay, now because of that, that generally means that you can get two equations from any situation. Okay, now you may not think that that's helpful, but in this case, I got two variables, right? I got a and b. How do I solve for two variables, a and b? Well, I'm going to need two equations. So, well, let's go ahead and let's write those two equations, all right? So we just said that if the two lines are tangent, that means that they will have to share a point. Now, that means that they intersect. You learned back in Algebra 1 how to deal with lines that intersect, and you learned that in Algebra 2 as well. What do you do when lines intersect? Well, you can substitute and you can solve for the point where they intersect, right? So I've already got y equals x squared plus ax plus b right here, and I've got y equals negative 2x plus 6 right here. So I'm going to go ahead and substitute this, negative 2x plus 6, into this one right here for the y there. So I'm going to get one equation that looks like this. Negative 2x plus 6 is equal to x squared plus ax plus b. Now that, of course, I can solve, I can rearrange a little bit, but not specifically very helpful right now because I still have an a and a b. Okay, well, let's see what happens when we use the other piece of information. Remember I said that when they are tangent, not only do they intersect, but their slope is the same. Okay, so I need the slope of this line to be equal to the slope of that line. Well, how do I get the slope? You find the derivative, Mr. Bywater. That's right, you find the derivative. Thank you, Mr. Bywater. Oh, you're very welcome. All right, so here we go. Derivative, well, derivative of y equals negative. Well, I don't really need to do the derivative of that one, right? This one you don't really need a derivative of because you already know the slope is negative 2. So I can say the negative 2 is equal to the slope of the other equation, the quadratic, which is going to be 2x plus a. And note that b was a constant, and the derivative of a constant is 0, so it goes away. And what just happened? Oh, the b went away. How about that? Now you say, but Mr. Bauer, I still got two variables. No, you don't have two variables. Why don't we have two variables? Because we know that this is occurring, these two slopes are equal when x is 1, which was up here at the top. So we go ahead and put the 1 in, and so we end up with negative 2 equals 2 times 1 plus a I got 2, subtract the 2 to the other side, so negative 4 equals A. How about that? We just got A. Now, how do you get B? Well, of course, you use the other equation, just like you do when you're solving for linears or double quadratics or whatever else. So we're going to take the A and we're going to put it in, and of course, we still know that x equals 1. We're going to put all that information in together, and we're going to get negative 2 times 1 plus 6 equals 1 squared plus a, which was negative 4. So we're going to go minus 4 times a, which is 1, plus b, and we can now solve that. So negative 2 plus 6 equals 1 minus 4 plus b. So 4 equals negative 3 plus b. Add the 3 to the other side, and I got 7 equals B. I have now solved for A and B. We did a fun question with 2 variables, and nobody's telling me to shut up yet, so we're going to do another video. How about that?